Hi, this is an explanation for problem 65 in chapter 14. This problem reads, a 500-gram air track glider attached to a spring with a spring constant of 10 newtons per meter is sitting at rest on a frictionless air track. A 250-gram glider is pushed toward it from the far end of the track at a speed of 120 centimeters per second. It collides with and sticks to the 500-gram glider. What are the amplitude and period of the subsequent oscillations? Okay, so to solve for this, oops, I think I just erased part of it. We're going to go ahead and use the equation mass 1 plus mass 2 times final velocity is equal to mass 1 times velocity 1, or the initial velocity 1, plus mass 2 times the initial velocity 2. So, plugging in values we're given from the equation, we're going to see 0.75 times the final velocity is equal to 0.25 times 1.2 meters per second plus 0.5 times 0 meters per second. Running these numbers, we find out that our final velocity is equal to 0.4 meters per second. Okay, so we're going to use this value to now plug into our next equation for the amplitude. Amplitude is equal to the square root of mass 1 plus mass 2 divided by k, which is our spring constant, times the final velocity. So if we plug in the values that we have, we're going to get the square root of 0.75 kilograms divided by 10 newton meters times 0.4 meters per second. So our amplitude is going to come out to 0.11 meters. Now, it also wants us to solve for the period. Our equation that we're going to use for that is t is equal to 2 pi times the square root of mass 1 plus mass 2 divided by k. Again, we're going to simply plug in the values that we have. 2 pi times 0.75 kilograms divided by 10 newton meters. It comes out to 1.7 seconds.